What is energy conservation? So I gave you the definition before that energy can't be created or destroyed, but it can change forms. That definition is totally fine. But I want to give you another definition that might be helpful as well. And that's that total energy remains constant. So the total energy you have is going to remain constant. So total energy remains constant. So the equation for this is that the energy initial is going to be equal to the energy final. Now, I want to be a little bit more specific in this equation for you to help you out a little bit more. So total energy is made up of your kinetic and potential. So the way that we would write this would be the kinetic energy initial plus the potential energy initial equals the kinetic energy final plus the potential energy final. Okay? And if you're thinking to yourself, hey, this sounds a lot like the conservation of momentum equation, that's because it is, right? That was momentum 1 initial plus 2 initial equals 1 final plus 2 final. This is kinetic initial plus potential initial, so the total initial energy plus kinetic final potential energy final, which is the final total energy. Okay, so what are the things you need to do when you solve the problems? So the first thing you need to do is you need to draw a diagram. We have not done diagrams yet for this unit, but you do need to draw a diagram. And I'll show you how to do that. Second thing you need to do after you draw a diagram is you need to label initial and final, because sometimes there'll be multiple places in your motion and you got to label where the initial and the final are. I labeled them as A and B, so I'm telling you that they're initial and final, but the way I have the equation set up is A and B. And that's just what I use for initial and final, just because it's easier to read, I think, on the diagram. But that's just a personal preference. You can do it however you want. And then the third thing you need to do is label where H equals 0. Which sounds kind of unnecessary because H is 0 at the ground. But there's actually a time where it might be better to put it somewhere else. And so I need to see where you're making your height of 0. So you label where you want H to be 0. And that's very easy to do. I'll show you that. And then lastly, you would solve and do your knowns and unknowns and the regular solving from there. So knowns and unknowns. And solve. Okay, easy enough.